Yeah, thank you. So it's starting to record now. Once I start the PowerPoints, obviously, I would have done that. Okay, so let's go to Cengage. Share that screen with you. All right, so just go to cengage.com and click Students. Now, if you already have a Cengage account, obviously you can use it, but if you don't, then you'll have to register yourself. I believe the very first thing you have to do is type in um, the name of either the textbook or the author. All right. Let me get the author's name in here. I don't think there's many Uts in their software. No, she has a couple textbooks, but let's get to the one. Here we go. Seeing Through Statistics, 4th edition. Right, so we'll choose that. Just click on it. All right, and then you have now. Let me see if we just simply click textbook ebook here. See what will happen. Now, for some reason, I remember that if you tried to do it through here, there was some issue. I don't know. Maybe there isn't. But you can buy just the ebook, nothing else. And it says here you can have access till May 27th. This is more of a rental. And it's $31.49. You could try that, see if it works. You can also rent the print book for the same price. So if you want the actual physical book as opposed to the ebook, it's the same price to rent it. So you can click this button here. Rent it. You don't want to buy it. It's obviously pretty expensive for buying it. So, but it gives you various options for, and actually renting it, you would need it probably until June 6th. This is the one you probably want to choose. So it's actually $39.49. That's the one you want if you were going to have the print book sent to you, but then of course you have to return it. The other option is to do Cengage Unlimited. And if this is good, especially if you have other textbooks that are through Cengage, and you can just click this, and for 4 months you can get the Cengage Unlimited for $69.99. So that's an option there. Okay, so you can do that if you have more than one course that uses Cengage, and then I think it's just the one price, and then you can get as many textbooks for the 4 months as you need. I believe those are the options. Digital platform, I don't think you're interested in that because that's probably more than you need. So try either one of those. Either go directly and just get the ebook itself without the Cengage Unlimited, and then you'll have that for 4 months or until the end of May, and it's for $31.49. So, and you can just add it to the cart. Let's say that's just what you were planning to do. Add it to the cart, and then let's see what it says here. Okay, I don't. Okay. So you could choose this if you want to, the Cengage Unlimited, or you can go with the $31.49. But the $31.49, did we just say that wasn't for the full until June, right? Let me go back. Hold on a second. Okay. Yeah, you want to choose this one, 35.99. That's the one you want. Or actually, that's just good. 31.49 is till the end of May. That's good. So add it, and then you would then go to view cart, I guess. See what happens when you view the cart. It says this is an instant access product. So it looks like if you just do the e-textbook, you'll gain access to it right away. All right, so you just do the secure checkout and see if it's going to, oh, see, you have to create an account. So they'll create an account. Once you create the account, I think it'll take you all the way through. That's how you would do it. Any questions about that? It looks pretty easy. So those of you who want to do it,
unlimited?
I'm sorry, say again.
How much was the unlimited?
$69.99. And again, you're not buying the ebook, you're buying that product, Cengage Unlimited, and you can have, again, if you have more than one textbook that you're using for all your classes that are Cengage textbooks, you can get the ebooks for all of them for that same price. You don't pay any extra for a particular textbook. All right, so those are your choices. Any questions? I think that's pretty self-explanatory. And then you'll have access right away, instead of having to wait. All right. So that's it. Let me see my email here. All right. No questions about that? All right. Now, also the a software program that you were mentioning to me, Desmos. I think I had sent you all an email about that. The only problem, and it seems to be pretty easy to use. I see there's many functions that we use during the course. The only problem is for testing. There's a sharing. You can share with people, email sharing. So that's obviously not a feature. I don't think it was designed for people to use while they were taking tests. They were probably to use it, if they were in, groups and doing projects together or something like that. So certainly not for testing. So that's the only problem with it. Otherwise, it's fine. It would probably be, it wouldn't do everything that the calculator does, but it certainly would do some of it. And I was checking with my calculator; it was pretty accurate in the answers that it was giving. So the only issue also was, of course, you'd have to enter in, data sets into Desmos, which again is not an issue. The data sets that we're going to use are probably pretty small, so not an issue either. It's just the sharing part of it. So that's why the calculator is the better choice. All right. Okay. So anything else? Any other issues for the beginning of the semester? Are we all good? Nothing? All right. So let me see what the time is. I think we have about 45 minutes left. So I think we can get through chapter 1 with no issue. So that's what we're going to do today, go through chapter 1. And let me share that with you. All right, so maybe I should go back one. The first one here. So this is chapter 1, and the PowerPoints, they've actually, this new edition, they've changed the PowerPoints where they have a PowerPoint for each section of each chapter. They used to have one for each chapter. So when I post these, they're going to be posted for each section. Just know that's way it's set up. So there's going to be many more PowerPoints files for you to use. Let's go to the, I don't want that. 1 second. All right, everybody can see this okay? I think you can. All right, so chapter 1 is just an introduction to statistics. And the answer to the question, of course, why study it? This is kind of pertinent to today's world. It says, without data, you're just another person with an opinion. And we certainly are living in times like that, aren't we? Where there are people, a fairly large segment of the population who believe that opinions are facts, and statistics is basically saying, well, wait a minute, we do have data and we do have the ability to agree on what the data is saying. So as opposed to opinion, we're going to use data to come to some conclusions about the real world. So that's really why we study it. I mean, I think everything we're going through right now as a country is certainly a testament to that. So to be an informed consumer of reports that have things like tables and charts and graphs, what do? Well, we have to learn how to extract relative information from whatever's being displayed. We need to be able to follow when we provide some number, we should be able to understand what that number represents. And we also should know something about how data should be gathered and summarized and analyzed. In other words, we have to know what the right way of doing it and what the wrong way of doing it, especially when we want to draw conclusions about an entire population and we're drawing data from a sample from it. We have to make sure that we're collecting it correctly. So this is what this course teaches you. And it's very basic, you know, it's not like we're going into great detail, because each of the topics that we're covering in this course, we can have entire courses on. So we're just scratching the surface, but giving you a basic idea of why to study statistics. All right. So this slide here, these slides actually have a lot of words on them, which is, when I create slides, I don't put too many words on here, but we can go through it. So we have to learn again how to collect data so that we can analyze it correctly. And maybe, just maybe, some of you will be actually doing this in your job, analyzing data and making decisions or coming to some conclusions and then passing it on maybe to your supervisor or something like that. So, or maybe you're going to be getting a master's degree or PhD in the future, and you're going to need to do research and learn how to actually do statistics or use statistics to support your research. All right. Now, what are the various steps that are used in analyzing data? Well, these are the 5 that this textbook talks about. Other textbooks use other or very similar criteria. One of the things that's not mentioned here is that we need to have an idea of what we're trying to accomplish when we're collecting data. In other words, we have to have a research question or some sort of idea or question about what we're interested in finding out. I mean, it's sort of common sense, but it's interesting that many students, especially on the graduate school level, have a tough time with that. In other words, they're given a, let's say they're given some project and say, we need to have a research project. And then they said, you know, then the student will then search for something. And what they end up coming up with is a very generalized topic. I mean, it's like this whole field that they're interested in doing research on, and that's their topic. And then whoever is the professional professor or whoever's supervising that research will say, no, you got to be more specific. And it really gets to the point where you keep coming back and going back and forth with that professor, and eventually you come up with a very, very specific topic. Very specific topic, very specific question that you're interested in. And you didn't realize that it'd have to be that specific, but it does, because then the very next step is to determine which data that you need to answer that very specific question. We're going to use the word variable to describe the type of data that we want to acquire. So it's very important to have that research question correct. Otherwise, you can go through this whole process collecting data and analyzing it, and it wasn't good. It wasn't appropriate. You wasted maybe months or years of your life on the wrong analysis. So it's important to get the question right from the beginning. It says here you may have to collect more information than what you did in the beginning. Well, the more specific the question is, the better able you will be to collect the information that you need. Now, where do you get this information from? Well, it could already be available in data sets that are out there somewhere, or you may have to collect it yourself. So it's always easier to find somebody else's data set that has the information that you need, but many times that's not good enough, and you have to collect it yourself, and you have to learn how to do that. And again, there's whole courses on how to collect data properly. We're just going to touch on it in this course. And then once we've collected the data, either our own data or somebody else's data, we need to analyze it. All right. Now, the analysis part of it could be that we just look at some what are called descriptive statistics and some basic charts just to get an idea of what the data looks like. We may want to double check the data to make sure it's accurate and there's no mistakes made in it. We want to look maybe for some unusual data points. Once we've done all of that initial analysis, then we may want to then do our more in-depth analysis using some of the procedures we're going to learn later on in the course, and then we draw some conclusions. All right, so that's really some of the steps that are used in in a research project using statistics. All right, well, that was pretty quick. That was the end of this first section. So we're now going to go to next section. And this one, I believe. So, you know what? I'm going to stop sharing and then choose the next one. I'm feeling that I'm going to see that. So, this is the one. This is section 2. Let me just double check. Yep. All right. So, what is so unique about statistics? Why don't we just use Microsoft Excel and run a few charts and graphs and be done with it? Well, there is a problem in that there is what's called variability of data. In other words, you can ask this, 50 people, or you can measure the height of 50 people, and you're going to get 50 different heights. Weight, 50 different weights, whatever we're measuring, or even a research question, we're going to get different answers to the research question. So there's some variability to data. So the question is, if we have a sample, a subset of the entire population's data, and we want to say something about the population, how can we do that when there's this thing called variability? Because it's possible that all of you do a sample from the same population, and you all get different answers. You may get all different answers. You may want to find, say you want to sample 100 people from Rowan University, and you want to find the average height of those 100 people. Well, all of you will do that, and all of you will probably get different different answers for the average height. And you would also have different amount of variability in your data set. So the question is, how can we estimate a population value when the sample values could change from sample to sample? That's really one of the issues we're going to be dealing with in this course. So this issue of variability is very important. If everybody was answering the same, having the same answer to the same question, there wouldn't be any problem generalizing a sample to a population. It'd be very easy to do. You only need one person in the sample because everybody's going to answer the same way. But that's not the way life is. Most variables aren't like that. And we have to learn how to deal with this variability. All right, so again, the methods we're going to use in this course are going to be dealing with the collection, description, and analysis of data. All right, and again, we have to understand this idea of variability. All right, so let's look at this as an example here. It says, as part of its regular water quality monitoring efforts, an environmental control board selects 5 containers of water from a particular well each day. And the concentration of contaminants in parts per million, ppm, is measured for each of the 5 containers, and then the average of the 5 measurements calculated. So this is a particular type of graph we're going to learn about next week. It's called a histogram. All right. And what is this histogram summarizing? The average contamination values for 200 days. In other words, we find the average of those for each day, and then we plot each of those 200 averages. And one way of doing this is through a histogram here. And what the histogram basically is doing is we're counting the number of these daily averages. We're counting them, and we're counting them in terms of how many of them were between 10 and 11 parts per million, between 11 and 12 parts per million, between 12 and 13 parts per million, like that. And the height of these rectangles are the number of these data points that fall in that range of averages. All right, so, and the sum of these counts, the heights here, the sum of these heights are going to be 200. There's going to be 200 of these when you can't add up all these heights here. The height is the frequency or the count. And again, we'll learn more about this next week. But this is one way of displaying the data. All right. And there's some variability here, obviously, right? There are going to be some days which have low average contaminations between 10 and 11. And there's other days higher, between 18 and 19 parts per million. And then there's other days where the average is going to be somewhere in the middle, and that's where most of the days are. You can see by this graph. So this is one way of displaying what we call quantitative data. All right, and it gives you sort of a visual idea of where the averages are on over the 200 different data points here. Where are they? This is one way of showing that most of them are in the middle here, somewhere between 12 and 16 parts per million. Most of them seem to be in that middle part. All right, now suppose it says a chemical spill has occurred at a manufacturing plant 1 mile from the well. It is not known whether a spill of this nature would contaminate groundwater in the area of the spill, and if so, whether a spill this distance from the well would affect the quality of well water. 1 month after the spill, 5 containers of water are collected from the well, and the average contamination is 15.5 parts per million. All right, let's see what they're saying here. Considering the variability before the spill, should we interpret this as evidence that the well water was affected by the spill? Okay. Well, we're not going to really answer the question right now, but look at the average. 15.5 is the average. All right. And where's 15.5? It's a little bit above the middle of this histogram, right? It's over here somewhere. 15.5 is in this, 15 is 16 parts per million rectangle. It's in here somewhere. And so the question is after that event, is that particular 15.5, is it unusually high, given the other 200 days that were measured previously? Now, if you look, you probably say, no, it doesn't look unusually high. Maybe if I got maybe something greater than 18 or 19, maybe out, 20, 21, 22 parts per million. Yeah, it seems to be outside the range of these values here. Yeah, maybe it is unusual, but 15.5 doesn't seem unusual. So your initial response might be, doesn't look like there was much of a change. But the question is there some quantitative way of actually coming to that conclusion? And the answer is yes. We'll be able to do that a little bit later in this course. We'll be able to come to some quantitative conclusion about how unusual 15.5 is relative to everything that happened before. So that's the type of question that's asked during this course, all right? And the type of reasoning that you need to use. Now, right now, we don't have any quantitative tools right now to come to any conclusion, but just by looking at the graph and looking at 15.5, you might say, hey, it doesn't seem like it's unusually high. Now, if you got an answer like 22, you might say, hey, that does look unusually high. Maybe I should look into it. But 15.5 doesn't look like it's unusual. All right, so that's really some of the topics that we're going to be covering. And again, the types of things that we're going to be, the math that we're going to be using is pretty simple. It's not really complicated. We're not using calculus or trigonometry or anything really advanced. We're using simple calculations, simple arithmetic, all right? Even algebra, even the only algebra we're going to be using, to be honest with you, in this course is when we get to what's called regression, where we have two variables and we're looking at a straight line that goes through some data points, and we want to know the equation for the straight line. That's it. And then that's just a small topic. Most of the other things we're going to be doing in this course is just arithmetic. All right. Now, some of the arithmetic may require you to use your calculator. It'll just be easier to use your calculator. It'll be a time saver. But in all essence, it's just arithmetic. All right. So one way of looking at variability is so that you're able to distinguish between what's considered a common value. That's a value which is that's occurring, that would be naturally occurring to just regular variability of data. You can call it just a random event that's not unusual. Or we could have an unusually small or unusually large value, right? So those are types of values we're going to be looking at also, because that's what statisticians do. They want us to look at unusually small or large values. Number one, there could be some error. Maybe somebody who entered the data into a computer entered it incorrectly, or if it is correct, we probably want to know why are we having data points that are unusually small or unusually large. All right. So that's one of the things that we want to use in statistics, is the idea of unusual values. We're going to be using that idea later when we deal with the third part of the course, which is called inference. I think I might have mentioned to you last time, there's really three parts of this course. The first part is an introduction to data analysis, which is called descriptive statistics. Basically, some elementary graphs, elementary data, summary data, such as the mean and the mode and the median, and just just the ability to just make some general conclusions about what the data is. Is it bell-shaped? Is it Is most of the data on the low side, most of the data on the high side, that type of thing. That's what descriptive statistics is all about. The second part of the course is probability. We're going to be using probability to come to conclusions in the third part of the course, which is called inference. So inference uses this idea of probability. We're going to learn the basics of probability over a couple of days, and then look at particular types of probability events. One important one, of course, is the bell-shaped curve or the normal curve. We're going to learn how to use it and coming to some conclusions about data. So unusually small and large values is going to be determined by, in many cases, the probability of it occurring. We're going to learn how to calculate the probability that if we have a data set, what's the probability of a certain value occurring? Unusually large or unusually small value. And then we'll come to a conclusion whether that probability is so small that maybe our idea about that data set's not right. Maybe we need to change our ideas about the data set. So that's the type of thing that we'll be doing. All right, so that's it for that set of slides. So when I'll get to, we have enough time to look at the rest of it. So let's do the share. And let's see if this is the one. Let's see if it's the one. No, this is the one we just did. Right. This is the problem with these, they all look the same. So go back. And see if I can find the other one. Okay, this is second 3. Second here. Second 4. All right, just give me a second here. I have to find it. One second. There we go. What? There we go. All right. This section is called Statistics in the Data Analysis Process. Again, these are introductory sections. And I will tell you exactly the types of things that you need to remember for later when we take our test, and also for the final exam. The final exam, believe it or not, does have some questions from the very beginning here, but I haven't run into anything yet about that. So now, here is again the steps about the data analysis process. Again, step 1 is understanding the nature of the problem. I talked about that earlier, that the problem should be very specific. And then based on that, you have to decide what to measure and how to measure it if you do have to create your own data set. Data collection, of course, is important if you have to collect your own data set. You have to know how to do it. There's a process of collecting data in a random fashion so that we can generalize it to the whole population. So that's important. And then we have our data summarization preliminary analysis. That's the first part of the course that we're going to be talking about. All right, where we're just exploring the data and making sure that there's nothing unusual about the data set. So we're going to again have some summary data like the mean and the mode, and then looking at some basic graphs. And then the formal data analysis, this is what we'll be learning in the third part of the course. In that part of the course, it's called inference. And then we do interpretation. Now, here is some things that you need to know. All right. Basic, extremely basic. A population. What is a population? It's a collection of individuals or objects. It doesn't have to be individuals or objects about which information is desired. So again, if you're interested in the height of students at Rowan, then the population will be students at Rowan University. All right. Maybe we don't want to, or we think it's impossible to measure the height of every student. So maybe we're going to come up with what's called a sample or a subset of that population to measure their heights. All right. So a sample is a subset of that population. And the population is the collection of people that we're interested in studying. Now, many people, when they think of population, they think of, oh, the population of the United States or the population of the world. No, the population could be any population. It could be a school population. It could be a city population. It may not even be people. It could be fish. It could be the population of fish in a pond. All right, we have to define what our population is. And the research question, of course, helps us to define what the population is. And then the sample is just a subset of that we collect. Descriptive statistics, again, this is the first part of this course. It's the branch of statistics that includes methods for organizing and summarizing data. We organize data with descriptive statistics. In other words, like finding the mean, there's a formula for finding the mean, or we use software or a calculator to find the mean, and then we summarize the data. All right. Now, summarization could be the mean, or it could be a graph. We could have a histogram. We could have a bar chart, all sorts of charts that we can use. Inferential statistics, that's the branch of statistics. That's the third part of the course that takes sample data and generalize it to the entire population, so we can say something about the population. It is useless, literally useless, to have a sample that we've collected incorrectly and not be able to generalize it to the entire population. What's the use of it, right? It's only talking about that particular sample, and because samples change from, data changes from sample to sample, it's really a waste of your time if you don't collect it correctly, because then you can't generalize it. And much of the polling, for example, that's done over the internet, the polling that's done on the spot and all of that, completely useless. It's only polling. It's only the information about the people that are polled. It says nothing about the general population. So it's a real waste of time to listen to that stuff. All right. This is just an example of a study. All right, that's done. Let me see if it's even worth talking about it. All right, I think we could just read through it. It's called Increasing the Number of Chews Before Swallowing Reduces Meal Size in Normal Weight, Overweight, and Obese Adults. So it describes a study that investigates whether chewing each bite of food more before swallowing would result in people eating less. There's people who believe in that. So there were participants in the study. There were adults between the ages of 18 and 45. All right. Now, there you go. That's your population. All right. Adults between the ages of 18 and 45. So the study describes your population right up front. At the beginning of each study, each participant was observed as they ate 5 pizza rolls, and then the number of chews made before swallowing was observed in order to determine a baseline for that participant. So that's a fun study. Participants were then invited back for a second session on a different day. They were asked to eat their usual breakfast on that day and not to eat anything after breakfast. At the second session, all participants were provided with a platter of pizza rolls and were told to eat until they were comfortably full. They were also told they could request more pizza rolls if they wanted more. Each participant was also told how many times to chew each pizza roll before swallowing. Then each participant was assigned to one of 3 groups. So they described the 3 groups. Participants in group 1 were given a number of chews equal to their baseline. The participants group 2 were given a number of chews that was 1.5 times as large as the baseline. and the participants group 3 were assigned a number of Jews that was twice as large as their baseline. After analyzing the data from the study, the researcher concluded that people ate about 10% less when they increased the number of Jews by 50%, and about 15% less when they doubled the number of Jews. So there seems to be some evidence here that the more that you chew, the less that you eat. All right, that's the whole idea. But the question is, was it significantly different from the people who were just chewed about the same amount as before to make that conclusion? And that's where statistical studies have to use statistics for that, to answer that question. All right, so this is the type of data analysis that could be used. This is more of a scientific research study, an experimental study, as opposed to maybe what we call an observational study, where we're looking at, where we're not controlling the experiment at all. We're just observing data. All right, so let's stop sharing there. So in that particular section, section 3, we're interested in just those basic definitions of population and a sample, and also the difference between inferential statistics and the other type that was mentioned. All right. So let's once again go to the next one here. Let me make sure this is the right one. Yep, this is the right one. And we have about 10 minutes, I think. Let's see. I think it's this one here. I hope this is the right one. No, this is the one we just did. Sorry about that. Give me a second here. What I'm going to do is just exit out of the other ones here. Just 1 second. All right, let's talk about what's in this section. We're being introduced to the types of data. And this section here, by the way, you may want to make a note that it does have information in this section which is used, which is examined in our final exam. The core piece of the final exam does have information in here also. So please make a note. Now, it's very typical for students to forget what happened in the beginning of the course, because, you know, once the first test is over, you think you can just forget about it. But the final exam does test you on this chapter 1, and especially in this section here. So I'm going to make a point to point out to those things that you need to know. All right. Right here, types of data. All right. First of all, definitions. This is just general definitions. A variable. A variable, now the word variable is similar to what we use in algebra when we say variable. It's a characteristic whose value may change from one observation to another. You know, we might have a variable in algebra that's x, and x goes from, you know, 0 to 100. It's a real number from 0 to 100, something like that. A variable in statistics is something like height or weight, and there's a range of values for these. Or it could be something like brands of automobiles. So it may not be numeric. It could be something that's non-numeric. So that's what we mean by variable. And the data is the collection of the actual observations. So if it was height, if height is our variable, then if we measure the height of 100 people, the heights of 100 people is what is the data. The data is the 100 heights that we're looking at. Now, a univariate data set is a data set that has only one variable in it. Now, that you'll only find that in an introductory course in statistics. In the real world, you may have data sets with thousands of variables in them, all right? So the univariate data set is just created for a course like this so that you can understand the basics so you don't get confused and mixed up. So a univariate data set is a collection of observations on one variable in a sample or population. Now, there are two types of data sets, univariate data sets, and this is what you need to know for the final exam. All right, so I'm making a very important point right here. Categorical data is data that is categories, all right? Such as if we were looking at all the makes of cars on a used car lot, all right? It could be the name Toyota, the name Honda, the name Chevrolet. All those are categories. They're qualitative. They're non-numeric. We can't do math with them. All right, so categorical data, qualitative data mean the same thing. All right, they're categories. Hopefully that makes sense to all of you. And then the second type of data set is called numerical. Now, you have to be careful. It says numerical data set is when there's a number, but I would clarify that by saying it's not just a number, it's a number that we can do math with. Let me give you an example. If we were going to rank, let's say pre-pandemic, maybe in the year 2019, we were going to rank the 100 highest grossing movies, all right? And we were ranking them based on how much money the movie made worldwide. So ranking number 1 would be the highest grossing movie. Ranking number 2 would be the next highest grossing movie, like that. The ranks 1, 2, 3, 4, 5, all the way up to 100. Those are numbers, but they're not. Those numbers would not be a numerical data set. Those numbers would really be categorical, because we could replace those numbers with the words 1, O-N-E, or 2, T-W-O. We can easily replace those numbers with words, and it would mean exactly the same thing. So the rankings are not numerical, even though we could use numbers for them. If we were going to have a, let me think, the day of the, not the day, yeah, the day of the week, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, or we can list them as 1 through 7. Well, those numbers are not numerical; they're categorical, because you can replace them with the words Monday, Tuesday, Wednesday, Thursday, up to Sunday. So numerical data sets, yes, each observation is a number, but we can do math with it, like heights. We can do math with it. We can add up all the heights in a data set and divide by the number of people in the data set, and we have our average height. All right, that's what we mean by numerical data set. And with a numerical data set, let me just skip some of the stuff here. I'll get back to it in a minute. This is also what can be tested in the final exam. There's 2 types of numerical data sets. There is what's called discrete and continuous, and you should be able to recognize the difference between the two. A discrete data set means that the variable can only take on a limited number of values that you can actually plot as dots on the number line. All right. So an example would be the number of days in a week, right? That a person, the number of days in a week a person exercises. Well, the answers could be 0 up to 7, right? Either you don't exercise at all, or you can exercise up to 7 times a week. So the answers are 0, 1, 2, 3, 4, 5, 6, 7. Those are all the possible answers to that question. That's a discrete data set. There's only 8 possible answers: 0, 1, 2, 3, 4, 5, 6, or 7, the number of days in a week that you exercise. A continuous random variable is where we have a range of values, and any value in between the endpoints of that range is possible. And that's basically almost anything that we can measure. All right. Anything that we can measure, like height or weight. Even though we might say, hey, wait a minute, you know, there's a limit to how the number of heights that people have. Yeah, that's true, but that's probably has something to do with how we measure the height. You know, if we were able to measure it to 10 decimal places, the height to 10 or 100 decimal places, we would have many more possible answers to the question, what is your height? So anything that we measure basically is a continuous random variable. All right. And it's basically any value, possible value between two values on a number line. So it's an interval of values as opposed to individual values, which is a discrete variable. All right. So that you have to know the difference. You have to be able to recognize, and given a particular type of variable, whether it's discrete or continuous. So two types of numeric variables, discrete and continuous, and the other type of variable is called categorical, or also called qualitative. Any questions about that? Next time, I think what we're going to do, I'll show you frequency distributions next time, because it's going to be a lead into chapter 2. So we're going to stop there. I do want to mention a couple more things that are in here. Bivariate data set means there's two variables in a data set, and multivariate means there's more than two variables in a data set. Those are additional definitions, but we'll start right here and go right into chapter 2 next week. All right, it's a good place to stop. All right, any questions? No questions? All right, so next week we're going to again start chapter 2. We're going to start getting into the meat of the course, so to speak, and it'd be good to have your calculators ready to go, because I'll start showing you next week how to use your calculator. All right, and actually, give me a second here. I might be wrong about that. No, it's actually chapter 3. So chapter 2 is not using a calculator. That would be on, we'll be doing that on next Monday, and chapter 3 is next Wednesday. We'll start going into chapter 3 next Wednesday. So you still have until next Wednesday to get your calculator before I start doing demonstrations. And it won't just be me talking the whole time like it was today. All right, it'll be demonstrations. I'll be showing you step by step how to do things. Okay, any questions? No, it kept you over a little bit. So I'll if no other questions, I'll stop the recording. This recording, by the way, by the end of the day will be in Canvas. I put the recording in the module for the week's that week's module. That's where you'll find the recordings, and that's what you'll find. Everything, the PowerPoints and everything for that week will be there. When we have quizzes and tests, it'll be in that week's module also. So that's it. All right, any questions?
No,
All right.
thank you.
Good. I'll see you guys next time.
Thank you.
All right, take care.
Thank you.
Have a great weekend, Professor.
Yeah, you too. Take care.